Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve the second question, that is question number 34 of the first paragraph of 2017 JEE Advanced Physics paper. Students, let us solve the next part of this question, that is question number 34. Question number 34 says, in process 2, the total energy dissipated across the register ED is. This is process 2. The process 2 is depicted here in the graph, voltage and time graph. This is the process 2 which attains the voltage V0 finally in steps. There are three steps. One is that once you give a voltage of V0 by 3 for a certain time set t, and that time is much greater than RC, the time constant of the circuit. So it extends up to certain time t and the voltage is maintained V0 by 3. After this time, we step up the voltage by this amount, so it becomes 2 V0 by 3, and that also continues for the same period of time t. So the total time is now t plus t, that is 2t. Next, we increase the step once more. The step we increase the voltage by this amount. So 2 V0 by 3 plus V0 by 3 is 3 V0 by 3, that is V0. So in 3 steps, 1, 2 and 3. So these are the, finally it attains a voltage V0. Now we have to show that the energy dissipated ED, and you have to find that energy dissipated ED, and we have to see which of the following options is correct. Now the energy dissipation in the circuit can be done by, first of all, when we have I'll just help you in the form of a diagram. Suppose we have a capacitor, obviously that is a resistor, and we supply a voltage. This is for process 2. The voltage is increased in steps. Initially the voltage was V0 by 3, then it goes to 2 V0 by 3, then it goes to V0. So when the voltage is V0 by 3 and the capacitance is C and the resistance is R, and sufficient time is given, then the potential difference across the capacitor. So in this process, first step, the potential difference across the capacitor will be V0 by 3, because the capacitor will attain the potential difference of the battery voltage after a very long time. So the potential difference is this and the capacitance is C. So if I want to find the charge, then the charge at this time is C V0 by 3. Okay, this into this, that will give you the charge in the capacitor plates plus minus. So this much of charge is in this plate, and this much of charge will be in this plate. This is positive, this is negative. Similarly, if I, so how much this is the, in the second case, here it is CV0 by 3 and minus CV0 by 3. In the second step, if I use another diagram, then exactly what is happening, it is the capacitor, now is a resistor, there is a battery and it is 2 V naught by 3. This voltage is given. So when this voltage is given, the potential difference across the capacitor will be 2 V naught by 3. Finally it will attain this voltage. So in this case the potential difference in this situation will be 2 V naught by 3, and this is 2 CV naught, 2 by 3 CV naught. This 2 by 3 V naught into C, so 2 by 3 CV naught. This will be the charge. Now similarly for this, if I want to write, then the final potential difference will be V naught if I give a V naught, and the final potential will be V naught, and here the charge will be CV naught. Now from here to here, how much charge is transferred? The charge now here was CV naught by 3, because the battery is not disconnected, or the capacitor is not discharged while upgrading to the voltage. You can see that the voltage is raised to this without discharging the capacitor. That means the capacitors that was previously charged with the voltage V naught by 3, the charge remains there. So charge remains there. From this charge to this charge it moves. So from this charge to this charge, how much charge is transferred? So initially it was here, now it is here, 2 V naught by 3 here. So obviously there is a charge transfer of CV naught by 3. This plus this becomes this. Similarly from here to here, how much charge is transferred? So obviously it is CV naught by 3, because if I add this to this, then it becomes CV naught. So by in each step of when you upgrade the potential difference, the battery voltage, the charge is accumulated by this amount, that is CV naught by 3. So initially it was 0 to CV naught by 3. That is also one step, you can say. So each step it is adding CV naught by 3 charge. Now we are concerned with what is the loss of heat loss, or energy dissipated, that is given as energy dissipated, that is heat loss, total heat loss during the process. This process starts from here and completes here. So during all these steps you have to find how much heat is lost and then add them up. The total heat loss can be calculated in steps. Heat loss during this process and this process. There are 3 steps to have this. So what are these 3 steps? First, 0 to the capacitor is charged from 0 to V naught by 3. So during that time, whatever is the heat loss, I say that heat loss is H1. Here I will say heat loss is H2. Here is H3. So this is H1 plus H2 plus H3. This is the total heat loss. Now the total heat loss can be calculated as follows. We know that when there is a capacitor C and a resistor is there, obviously because heat is lost through the resistance, and there is a battery voltage V here and resistance R. So finally this attains a potential difference of V. Finally the energy stored in the capacitor is half CV square, but the battery which supplies the energy is the charge that flows through this, that is CV, into the battery voltage, that is CV square. This is the energy supplied. So the energy supplied by battery is CV square, but energy stored is half CV square. So that is what is lost. Lost is half CV square. This is a heat loss. This is a general expression for heat loss. So this is one expression for this particular example. This is how you calculate the heat loss. So that means whatever energy is supplied by the battery and how much energy is finally stored, the difference goes into heat. In the first step of 0 to the charge is now, the battery voltage is now V naught by 3, then V naught by 2, 2 V naught by 3, then 3 V naught by 3, that is only V naught. So from here to here, the energy, that is the energy, final energy stored in the capacitor is half of C V naught square, that is this square, minus the work done by the battery, and the work done by the battery is this is the energy stored, and what is the work done by battery? You have to subtract this number from the work done by the battery, that is C into V. How much charge that flows into that? The charge flowing was, I told you the charge flowing was CV naught by 3. CV naught by 3 was charge flowing, and the battery voltage which was V naught by 3. Okay, did you understand? This is the charge flown through, and this is the battery potential. So this into this minus this is the heat loss. So this comes out to be C V naught square by 9 minus C V naught square by 2 into 9. This is 9, this is 2. This is the heat loss during first step. During second step, we will again repeat the same process. Initially, the charge is there, initial charge is there already, and only the change in the charge that is taking place is CV naught by 3. This is the charge that is being transferred in each step. So from here also the charge transfer is CV naught by 3. So battery voltage, you know, so this I keep it here, and for this I will use what was the battery voltage? Now this is the battery voltage. How much charge is transferred? This is the charge transferred. So multiplication of these two is the work done by battery. So this two multiplication gives you 2 by 9. These two multiplication CV naught square minus the final energy stored in the capacitor. But before you consider the final energy stored in the capacitor, we know that already there was energy in this place. There are some initial energy, and this is the final energy. So this energy minus this energy is actually the energy stored in the capacitor, and this is the work done. Now, what was the energy in this case? Half C V naught square by 9. That is, this was the energy. So I'll write this minus this. The energy stored here minus here. So work done by battery minus final energy in the capacitor. Final energy is half C this square, that is 4 by 9 V naught square minus this one, that is half C V naught square, that is by 9. This is what is the energy, final actual energy that is stored, because it was already there and now it is here. The difference is the energy stored out of this is stored, so the difference goes to the heat. So this is the situation. We will have to solve this. This is my H2, this is my H1. So this I have to solve, I'll get H1. This I have to solve, I'll get H2. Similarly, I have to solve this one to get H3, and you have to add them up. So If I solve this, I am getting, you can see one thing that if I add it, if you will see that this minus goes, this becomes plus. This becomes plus, and this number is there. This is minus. So this will cancel out. So instead of solving, better we'll write this first and then simplify and cancel the possible terms. So now moving to the third part of the steps, that is it is changing from 2v naught by 3 to 3v naught by 3, that is v naught. This is only v naught. Here also the charge that is transferred is CV naught by 3. Here what was the initial energy stored? Initial energy, that means in this step the final energy that is stored is half C of square of this, that is 4V naught square by 9. This is the final energy stored. Now from here we are energy changing to this one, that is half CV naught square. So what is the difference? The difference here it is the difference I will take first, and the difference is half CV naught square minus half 4 by 9 CV naught square. This is the difference of energy that actually is transferred, and the work done by the battery, it has to be subtracted. This work done by the battery, this work done by battery is the charge, and the final is this one. The charge that is transferred is this, and the battery potential difference is V naught, so CV naught square by 3. So this is to this number. So heat H3 is this work done minus this value, that is CV naught square by 3 minus of this value. So this becomes minus, this becomes plus. Minus half CV naught square, final energy in the capacitor minus initial energy in the capacitor. So I'll take the difference of these two, final minus initial. So final is this, so it becomes plus, and this becomes minus. Minus this, and this becomes plus. Okay, half of 4 by 9 CV naught square. I'm not cancelling this because I will have to use it somewhere else. So why should I change now? So these are the all three heats that I obtained. So these are the three heats obtained, and I will just add them up. The total heat dissipation, dissipation can be obtained by the following: H is equal to H1 plus H2 plus H3. If it is so, then what was my H1? The H1 was CV naught square by 9 minus 1 upon 18 CV naught square. You can see H2 here I will write in red, I will write. This is for H2. H2 is this plus of 2 CV naught square by 9. This is minus, this becomes plus, so this becomes minus, or minus of 1 by 2, 4 by 9. This is multiplied CV naught square, and this becomes minus, this becomes plus of half CV naught square divided by 9. That is 2 9s are 18. That comes out to this. So this will cancel out. And what about H3 plus of H3? H3 is this one. H3 is this one. So it is CV naught square by 3. I'll write another pen. Minus half CV naught square plus 4 divided by 2 into 9 CV naught square. It is there. Just I copied this from here, and we have to solve it. This will cancel. This is plus 4 by this, and this is exactly the same, but this is negative, this is positive. This will also cancel out. Similarly, here it is now what is left is 1, 2, 3 and 4. So let us see how much it is. This is 2 by 9 CV naught square and this is C by 9 CV naught square, 1 by 9. So it is 3 by 9 CV naught square. These two terms will give you 3 by 9 CV naught square. And these two terms together will give us, so let's write CV naught square by 3 minus half CV naught square. If I take, this is actually 3, 1/3 CV naught square, and this is 1/3 CV naught square. So this is 2/3 CV naught square minus half CV naught square. Now the total heat that we got is sum of heat loss during each step is finally coming down to 2/3 CV naught square minus half CV naught square. 2/3 CV naught square minus half CV naught square. If I solve this, then I have to see first the options what is given. Then in the form of that options, I will solve that. The option are okay. See here, this is the option. I'm getting how much? This one, and this is of this form. So obviously no problem. Half CV naught square I'll keep here. So this actually comes out to be 6 of LCM, and this is 4 CV naught square. Okay, it's 4 CV naught square, and this is minus 3 CV naught square. So this is 4 minus the 1, so CV naught square by 6. This should be the answer, and this is half CV naught square, this is 3 by 2, this is 1 by 6 CV naught square, this is actually 1 by 6 CV naught square. If you multiply that, half CV naught square by 6, and we're also getting CV naught square by 6. Or in this form, I can write this as 1/3 half CV naught square. You can write this way also. So this, therefore, this is the answer to this question, and option number 3 is correct. Option number 3 is correct. So ED is CV naught square divided by 6. This is the answer. Okay, thank you.